anytime that you look at some new material and you start looking at some concepts or some new components, one of the first things you start thinking about is, well, what is the application? And seeing as we've been talking about diodes, I want to talk about diode applications. And although one of the largest areas of application is power rectification, and we will be talking about that in future sessions. What I wanted to do right here is, I mean, there are literally hundreds and hundreds of different types of diode circuit applications, but I'm going to show you a few interesting ones. Some of them you may run across, others maybe not, but just to give you an idea of how diverse really the uses are. And so what I have is I have several drawings of diode circuit application where diodes are used, and I want to just go through them one at a time and explain what's going on. And this will just give you a little bit of an idea. So going to show you the first circuit right away here, and you should see a solar collector charging a battery. Now, alternate energy between well, all the different applications, honestly, but solar, wind, many different instances where diodes are used. So with this one, what we see here really is the solar collector cell, and starting at the positive terminal, we would see the flow of charging current that would come this way up to the diode, from the diode to the positive terminal. And as the, as long as there was lots of light on that cell, then you would be looking at a situation where the current would be flowing into the battery and the battery would start to fill. And as it filled, the charge goes higher and higher. Once the battery is full, essentially the flow of current will slow pretty much to a stop. Obviously, if you had 2 or 3 batteries, you need to fill them all to the same level. Now, what is the purpose of this diode? Well, as the current flows, you can see that it will flow through this. In other words, the solar collector is forward biased with respect to this diode, so the current goes into the battery. And in the absence of light, so when it gets dark out and this solar panel no longer has light falling on it, producing the voltage, interesting fact, what happens is the current without this diode, the current from your battery source here will actually feed the opposite way back into the solar collector. The solar collector will actually become a load to the battery. And so as through the darkness, you would actually lose your charge and it would be going back into the collector actually and dissipating off. So this really is like a backflow prevention. So you can see that it's forward biased with respect to the solar collector and reverse biased with respect to the basically your storage medium. So solar collectors that are actually in shade even will, where there's a difference, like if you have an array of several panels, one of them is shaded, there can be enough difference where it will actually start to reduce the amount of charge that the other panels can produce. So these diodes are an important part. In many cases, actually internally wired right with each cell. All right. Now let's take a look at the next example. All right, wind generation. Here we've shown a wind turbine, and what happens is that usually this wind turbine is it's generating AC voltage, and then it's normally rectified down to your positive and negative to your DC. So we would see some current coming from the actual positive terminal, and then it would be flowing down through that diode and to the positive terminal. Interesting thing with this, when you think about the conditions that are needed to generate, well, you would have wind blowing on this turbine. It would be turning. In this case, I'll show it turning in this counterclockwise direction. That would be producing voltage and charging the battery. And so as the battery fills, the voltage starts to come up. And once the storage battery is full, we could continue to push here, but this current would fall off to pretty much a very low level, and when it's full, it would pretty well stop. Now, what are the conditions that we would have that would be a problem here with this wind turbine? Well, in most places where wind turbines are used, the wind tends to be pretty constant, but what would happen is, in the case, and of course it can happen, in the case that the wind stops or it's so low that it can't, at least it can't really generate, what could happen is that now the charge from the battery, if this diode was not present, this charge would become the source, and current would now flow into the wind turbine, and that generator would actually become a motor, and it would act like a large fan. So it would be motor driving the fan blades, and so it wouldn't take very long, as you can imagine, to empty the battery. And so what would happen is, as the current flowed to the motor, battery would empty. When it was empty, then everything would pretty much come to a stop. So very, very important in these two alternate energy applications: solar panels and wind turbines. Okay, the diodes are typically connected in the positive line, and they are forward biased from the source and reverse biased to the storage medium. Now, I'm going to clear these pictures out of here, and I'm going to move to another drawing. Now, this is an interesting circuit. I just want to explain a little bit what this one is about. A number of years ago, I worked for a company. We sold flare ignition equipment. So the panels that I built were used to control high voltage to an igniter that would ignite flare gas in flare stacks. So the panel that we produced would be shipped to remote locations all over the world, but at that time mostly it was the market that I was involved in was northern Alberta and northern BC. And so what would happen is we would send these panels out, and very frequently they would be set up by either a contractor or somebody on site. They didn't always get us to come and do the installations. So what would happen is quite often they would connect the panel with the incorrect polarity from their 12-volt deep cycle battery. And unfortunately then what would happen is it would, as soon as they basically powered it up, it would burn out a very expensive electronic circuit board that was part of the panel. And so it was partly the cost of the card, which was well over $1,000, but it was also just the inconvenience of getting one shipped and so on. So it was initially a problem, and so we did a little work on it, and we designed the circuit with a polarity protection for the connection. And let me just show it to you. We'll see what it looks like. So here we had the circuit. I haven't shown the entire connections. There would have been a number of leads connected to the actual circuit card itself. but I just wanted to look at, I actually just want to look at the main power circuit. So um, right over here, you can see this would have been my positive terminal, and we would have had power that would have come in. It would have come to this point at the fuse, would have gone through the fuse and up to the switch right over here. Now, as you can see, because there's another line connected right here, power would have also gone through this line up to the cathode of this diode. Now, because that is actually reverse biased with respect to the source, no current would flow through there. So as soon as we close the switch, then we would have power moving through positive to negative through the load and back to the negative terminal, and that would complete the circuit. Now, if, for instance, somebody accidentally were to connect it in this way, and let me show you, if we made this positive and this negative, and this is the accidental thing that could happen. So a lot of times these wires would be connected up, and the final step would be to connect the leads, these incoming leads, to your battery source down in the battery chamber. And so if the connections were done in such a way that this would become positive and negative incorrectly, then here's what would happen. And let me just clean this up a little bit so we can see. So what would happen is the positive would now be coming to the what should have been the negative terminal, and negative to what should have been positive. Now, if this is positive, what happens is this. The anode would become positive to a positive potential. Now that's forward biased, so we would have flow through the diode immediately up to this point right here at the fuse, and a direct shot back to the negative terminal, which means current flowing through the fuse, fault current, like short circuit level current, and immediately actually blowing the fuse. And so what we would have is this fuse would be taken out of the circuit as soon as they connected their supply. So the current never getting a chance to flow through the other line, through this line here. Potential would have come up to here, but no current flow because the switch was open. And so when would the fuse blow? Literally as soon as they connected the battery into the circuit, it would blow the fuse. And so really basically, brought the number of problems that we had with that pretty much to a stop. And this type of circuit, this type of polarity protection circuit is used in many different applications throughout many different industries. Okay, so the idea of polarity protection using diodes, very useful feature. Now, I'm going to clear this drawing, and we'll move to the next one. All right, this is something that that some of you may have had some experience with. I've taken and tried my best here at drawing a V8 motor, and what this would really what this would signify is you would be looking at an engine from, now this could be in a boat, this could be in an RV, like a RV type unit, motorhome, could be in a truck and camper, could be just a truck, off-road truck. And the applications where you need an auxiliary battery are many. So in a boat, you use the auxiliary battery for cabin lights and cabin appliances. In an off-road truck, of course, you're running winches, sometimes large lights, things like that. If it's RVing, you're using this auxiliary battery for things like stereo systems, lights, appliances, many different things that you would be using while the vehicle was off. So you want that auxiliary source of power. Now, the issue with this is fairly simple. You want to be able to use power from this source over here without affecting the level of charge in your starting source. And so when everything is said and done and your first battery is, well down, you still want to have enough energy in your starting to be able to start the motor. So let's take a look at how this actually works. And I'm going to start by putting in a line, and I'll just show you how the voltage, where it starts. Now this is your alternator up here. And so the charge would come from the positive terminal in your alternator. Now this is if the engine's running, right? If the engine is running, this comes to this point, and this is called your isolator. Inside the isolator are two diodes connected anode to anode. Now that means that the current will flow through this one, and it will charge this battery. Okay, and it will also flow in this direction and charge this battery. So no problem, as long as your alternator is working, it will charge either battery. And obviously if the starting battery is already charged, well, then most of the current basically just flows this way. So it all has to do with voltage balancing. If the starting battery is full, then the alternator can spend most of its energy filling the auxiliary battery. Now, when the engine's not running, then this is not going to be, there'll be nothing going on there. So now what you have is you want to make sure, and this is where we should be sitting at. So let me show you the condition that we would be hoping for. We should have our auxiliary battery should be full, and our starting battery should be full. And so now you've shut the engine off, and what you want to do is basically enjoy yourself. And so what you do is you start using the energy from your auxiliary battery. Okay, so this is going to the loads. Now, seeing as this is still connected, watch what happens. This potential comes up to right there, and that's as far as it goes. It's blocked at that point. So in other words, nothing is going to go from your auxiliary battery into your full battery, into your starting battery. And at the same time, even though you have, from here, you've got power that is available up to your starter. So as soon as you turn the switch, it'll start. And you also have power, but it only goes up to the isolator, and it's blocked at this point. So no flow from the starting battery to the auxiliary battery. And so what happens is, you can just drain it down over here, and you're going to see that this battery is pretty much going to go, and it's going to empty out. And at that point, when you have no more voltage over here or close to it, you're going to say, well, it's time that we start this thing up, get the alternator going, and charge up our auxiliary battery again. So here you have a starter battery that's full. You start the engine with your starter, and then at that point, you go back and you start again on your from your alternator on your fill side. And here you go again, comes in here. Now what happens here? Well, the voltage of your starter battery much higher than the voltage of your auxiliary battery. So for the most part, all the current is going to go this way. And you've got voltage up to this side of the diode, which is blocked there. Very little, if anything, will go through there. It's going to go this way. And of course, what you're going to do is you're going to start down here, and you're going to run your engine, and this one's going to refill again. Okay, so that gives you an idea what goes on here. What we're really doing is isolating the two batteries so that they can function properly without one draining the other. Okay, and you always want to have power in your starting battery. Okay, let me go ahead and clear this drawing, And let's go ahead and take a look at the next one. Now this is an interesting circuit, kind of a very opposite function to the last one. And so in many cases, what you have is you have actually a source. And so I'm going to show you that here. This is a source that is really only a charger to the extent that it keeps battery A and battery B full. And at the same time, it supplies voltage through this diode, and to the load. And at the exact same time, so in parallel, it supplies through this diode, and down the same line to the load. So the source is literally passing a current through two sets of diodes to the load. Now at the same time, it's making sure that it keeps this battery A and this battery B full. Now, when the source is providing current to the load, and of course, this is coming back to the neutral here. Okay, so there's your source essentially operating the load. Now, what would happen if your source went down? And so I want to show you the new circuit. Your source essentially does this. Okay, source packs it in. Now you have two backup batteries that are both full, and they're going to provide voltage and current for the load. So they look like this. Now you're going to start from your positive terminal. You're going to come over. It's going to go. When it gets to here, it's blocked. And if you come from this battery on the positive terminal, same thing, blocked. So this cannot push charge back into the source. And in many cases, an actual source can become a bit of a load depending how it's arranged. So you really want to kind of isolate it. So these two diodes closest to the source are actually blocking the current from the batteries from going that way. However, the path they do have is through this diode, and to the load. And as you can see, now the neutral is a different path. It comes back through this overcurrent and back to the battery. And this one, of course, down on this line through this overcurrent device and into the battery. So this is now your backup circuit. And the way that these two batteries are configured, they will draw down exactly equally. So the current will be provided actually, whatever the load current is, half from each battery. And as the total amount of charge in the two batteries goes down, they will stay balanced. The voltage will stay balanced because they're connected in parallel. So this is a really interesting circuit, really kind of the opposite of the last one where we had isolation. This one is literally two backup batteries set up to draw down exactly equally. So very interesting, different circuit. 4 diodes required for this one. Okay, let's go ahead and clear this and see what else we have got. Now this one is a little bit of a review. Some of you are going to remember when we talked about, probably in second year, when we talked about inductors. We know that inductors that have DC current flowing through them will tend to develop a large field around the inductor. So as the current flows through this coil, what we get is we get flux that builds up in a field around that inductor. Because it's DC current, it just stays there. It's like a stored charge. And the larger the current, the larger the amount of stored charge there is. Now, one of the problems, of course, is that in order for that to happen, this switch would be closed. Now, when we actually open the switch, what happens is, because of this large amount of charge in the field, when we try to open the switch, which is essentially cutting the voltage to zero, as the voltage falls, the current tries to maintain. And so what we get is this large sort of a fuzzy arc across the switch. And what we want to do is we want to minimize that arc, because what that arc does is it does a lot of damage to the switch contacts and things like that. So let's start when everything is good, when the switch is closed and there's field around that, the current is flowing through the switch. Let me just follow it this way. It's flowing through the switch, comes down, stops there because that's blocking at the cathode, flows through the load, down, and out to the negative terminal. Now, when we open the switch, so this is going to be the kind of the opposite event. When we open the switch up here, we don't want this arcing going on. And so here's what happens. If you look at the circuit, now all of this energy that's stored in here can actually go like this. It can go through here, through that field winding, through this portion of the circuit up to here to this terminal, comes this way. Now it's forward bias, and go through this diode, out of here, into this contact, and back through here. So it now has a complete loop through this diode, which we call we call this diode a field discharge diode, and it's always also sometimes called a freewheeling diode. So field discharge or freewheeling diode, and it basically lets the energy in the field flow until basically it burns off the energy through the windings of the field. So a real interesting setup, and that one of course is used mostly with DC motors and other inductors in DC circuits. All right. Now this last one, this circuit is kind of interesting. This is something that we will be looking at a little bit later on, and but let me just give you a quick introduction to what this is. This component right here is an SCR. And what we have is the anode, the cathode, and down here, the gate. And so what happens is the gate, with comparison to the actual anode to cathode, has a very weak voltage rating. So the gate is not very strong. So the actual anode to cathode through that SCR, depending on the voltage rating of that particular component, but easily in the hundreds of volts. So in this one, 800 volts either way, forward or reverse blocking, no problem. But the gate, maximum reverse voltage, 5 volts. Well, if you're using this in a 120 volt AC circuit, if you did not prevent the current from flowing backwards from the cathode to the gate, see, the current always has to go from the gate to the cathode. If it goes backwards and you have more than 5 volts of voltage drop, chances are you're going to destroy the gate. And so what they do to make these work out is they usually put a diode that will be just placed right there in series with the gate, and we call this diode a gate protection diode. And so it's there to make sure that the current can only go into the gate and not come back. Okay, so lots and lots of different applications, and I'm sure that there will be more. We'll probably even talk about more that come up as we move along. But this gives you an idea. Some of the various different applications that we can have, interesting different circuits. And but of course, the main thing that we're going to be looking at is power rectifiers. And so that is going to be coming up shortly. We'll be looking at single phase rectifiers first, and then moving on to three-phase rectifiers. So lots to look at still, and so I just wanted to get those out there for you and give you a bit of an idea where we're going.